Alrighty, let's take a look at this question. So, fishing boat leaving a dock, here's our dock, at 5:20 a.m. travels due east at 20 kilometers per hour. That's this line here. A second fishing boat leaves the same dock 60 minutes later. I'm going to use 1 hour there just to keep the units consistent. Travels due north at 30 kilometers per hour. At what time of day to the nearest minute will the two fishing boats be 100 kilometers apart? Not an easy question. Okay, so you probably have drawn a triangle trying to figure this out, which is great. What we need to put on the triangle are the distances that each of the boats traveled. So we have to recall that distance is equal to speed times time, and time is actually what we're looking for. So time is going to be, we're going to call it T, and that's going to be the time of day from 5:20 in the morning in hours. We're going to use hours. So by using hours then, our speed of, say, 20 kilometers per hour, if you go 20 kilometers per hour times the number of hours, you get kilometers, which is what we want. So our expression for the distance the first boat has traveled would be 20 times t, 20 kilometers per hour times the time, t, which we don't know. Okay, now the boat that travels north, he leaves 60 minutes later or 1 hour later, which means its time that it's going to be traveling is 1 hour less. That's why I've used the expression t minus 1. And it's traveling at a speed of 30 kilometers per hour. So speed, 30 kilometers per hour, times the time, t minus 1, because it was traveling for an hour less than the other boat. Okay, and then they tell us that the fishing boats will be 100 kilometers apart. What time does that happen? So we can label the hypotenuse 100, and now we're ready to use Pythagorean Theorem. So the hypotenuse squared equals the sum of each of the other two sides, each squared, so 20t in bracket squared, plus bracket 30 bracket t minus 1 squared. All right, let's simplify that right-hand side. Well, we can do the left too. 100 squared is going to be 10,000. When you're squaring 20t, you have to square the 20 and the t because they're being multiplied. So you'd have 400t squared plus, and same thing in here, we have a 30 and a t minus 1. So 30 squared, actually I can just write that as 900. So 900. And then t minus 1 squared, we're going to have to expand that. I'll just do that off to the side. T minus 1, t minus 1. We're going to FOIL that. So we'd get t squared minus t, so minus 2t plus 1. All right, so now put that back in here, plus 900, and then bracket t squared minus 2t plus 1 that we worked out over on the side. Okay, one more thing to do on the right-hand side. We're going to multiply that 900 through. So 900t squared minus 1800t plus 900. And still have that 10,000 on the left-hand side. So what I see now is we've got t squared, so we've got t's, so this is a quadratic equation. So I'm going to bring the 10,000 over to the right-hand side by subtracting it on both sides. 400t squared plus 900t squared is going to be 1300t squared minus 1800t, still the same. And then 900 minus 10,000... 1 second, as I grab my calculator. Okay, 900, actually I could figure that out in my head. But negative 9100, 9,100. Okay, now, if you want to factor it, I would first factor out a greatest common factor of 100. So if we do that, take out 100, then the numbers are a lot smaller. So 13 squared minus 18t minus 91. That helped. Okay, and then we could use quadratic formula because I don't know offhand what that is to factor. So we'd go t equals negative b plus or minus the root of b squared minus 4ac all over 2a, and we're going to sub into that. So negative b is, let me just write these off to the side, what each of these are. A is the coefficient in front of the t squared, so 13. B is the coefficient in front of t, which is negative 18. And c is the constant term, negative 91. So we put that in, we get negative b, like negative 18, so positive 18, plus or minus the root of. And I know I'm going to square negative 18, so I'm just going to write 18 squared, because I know it ends up being positive anyways when you square something. And then we have times minus 4 times 13 times negative 91, all over top of 2 times a, which was 13. All right, let me throw that in the calculator, and we'll see what we get. Okay, so when we put in the plus 18 plus the root of blah, blah, blah in the calculator, I'm getting like 3.427. It keeps going forever. And when I put in the negative 18 minus the root of, I get negative 2.0425, yada, yada, yada. Now, time in this situation can't be negative, so we're ruling out that second answer. And we're going to take a closer look at 3.427. Now, that was 3.427 hours, and that means 3.427 hours added to 5:20 a.m. So, let's change that. Well, it depends on how you want to do this. We'd change 5:20 into hours by taking the 20 and divide by 60, so we get what part of an hour? So it'd be like 5.3 repeating hours plus 3.427, yada, yada. Let's see what that ends up being. Plus 5.2, and we get approximately 8.76, etc. Okay, now what that means is it's 8 hours and then 0.76 of an hour. So if we go 0.76 of an hour, change that into minutes, so 60 minutes in an hour, then we would have, so take that part of it and multiply by 60, and we get approximately 46 minutes. So that means it's going to be 8:46 a.m. And there we go. The answer is C. Whew, not an easy question. All right, hope that helped.